So let's start by writing out what our estimator for beta hat 1 was. So beta hat 1, remember we had these kind of ugly sums here, x1i minus x bar 1 yi minus y bar over that sum of x1i minus x1 bar squared. So remember, this was the estimators we derived kind of last week. So what we're going to do is we're going to concentrate for a few seconds on the numerator. So we're going to concentrate on this for a second. So let's bring just that part down here. That's what we're going to be working with. So the sum of x1i minus x1 bar, that's the average of x1. So we're just rewriting it here. Well, that's going to be equal to, I'll keep it in the same color and then use green to explain it, the sum of x1i, so we're going to keep this first bracket the same, and then we're going to plug in what yi equals and what y bar equals. And I'll kind of explain that right below. So with this second bracket equals, I'll explain why in a second, x1i minus x1 bar plus ui minus eu bar bracket. Okay, that looks good. All right, so let's explain. So we're basically expanding this second bracket to be equal to this long thing. I'm just going to write a quick note to explain that. So we know that yi equals beta 0 plus beta 1 x1i plus ui. So we know that, so we can kind of plug, so what we're doing is we're plugging this in there. Well, we can also subtract the mean of these. And remember, we can think of the mean, the regression passing through that mean point. So beta 1, so these beta zeros are going to cancel out. x1i minus x1 bar plus, ui minus ui bar. Oops, I don't need an I on the bar. Okay, so what's happening here is so this is just right from our regression, right? That's like the regression at the observational level or whatever you want to call it. And now we're just going to subtract the mean. When we subtract the mean, these beta zeros are going to cancel out because that's just the constant. It's going to be the slope. We're going to have both the x1i and this average of x1. So we're just collecting those terms times the slope. And then we have this second part of it. You can think of this together if you want, where we have the error term minus the mean error term. But we know kind of what that equals. Okay, so now hopefully this somewhat makes sense going from this step to this step, and we're going to start working with this in a second. We're going to start working with this expression. Okay? So let's rewrite that expression that we just figured out. So remember, it's the sum of x1i minus x1 bar, and then we had these square brackets with that beta 1 x1i minus x1 bar plus ui, and we'll put that in brackets as well, minus u bar. I guess this is a square bracket. Should be a square bracket. Okay, so now what we're going to do is we're going to take this first bracket and multiply it by here, and then multiply it by this second term as well. So we're just kind of multiplying that bracket through. And so that means this equals the sum of x1i minus x1 bar squared, right? So that's this first bracket, and multiplied by this beta 1. But notice that this beta 1 is a constant because it's the true value, so we're just going to leave it in the front there. And then we have the second term, right? So this first bracket times this second bracket. And so we have plus, if we divide up the sums, the sum of x1i minus x1 bar from here to there times ui minus u bar. All right, so that's what we did here. We multiplied this first bracket by this first term in the big square brackets, and then by that second term, and then we took this beta 1 out of the sum because we're multiplying by a constant. Okay, so now we're just gonna, we're getting there, don't worry. So equals beta 1 x1i minus x1 bar. So that's remaining the same. And then what we're going to do is we're just going to expand this bracket. So we're going to multiply this through by each of these. Apologies, it's getting a little bit ugly on the board here, just like in regular class. So we're going to do that. So plus the sum of x1i minus x1 bar times ui minus the sum x1i minus x1 bar times u bar. But we know that u bar equals 0, right? This is going to equal 0. Since we've kind of made that assumption originally that the expected value of u is equal to 0. Remember we talked about we can always kind of make that true. So now we can, so this is going to go away, and so let's just write out the last expression. So we just have it in one place. So remember, we're just working with the numerator of our parameter, of our estimator for that parameter, beta hat 1. All right, so this is, we've kind of transformed the numerator to look like this, and we're going to plug that back into our beta hat 1 formula and kind of simplify that. Okay, so we kind of figured out what that numerator looks like, but let's first rewrite the formula for beta hat 1, and then we can plug in what we just solved for with this numerator, right? This is kind of what we were working with. We're going to end up plugging that expression that we found back in here. So this is the normal formula for that estimator for beta hat 1, that slope parameter. And so now we can plug in what we found for the numerator. Like we just, numerator, I'll just write it out. So we just kind of, we're playing around, so to speak, with this numerator. So we're just going to plug in what we got for it. So beta hat 1 equals, remember we had the true value of beta 1, x1i minus x1 bar, that was squared, plus we had that second term, which was x1i minus x1 bar times ui. And then that last term, remember, was equal to 0. And then it's over the sum of x1y minus x1 bar squared. Now you can kind of simplify this just a little bit, right? So we're just going to simplify. Simplify. Okay. So if we separate these terms, we're going to keep the denominator there and kind of separate the numerator into two different terms. We can start canceling things out, right? So x1i squared, x1i minus x1 bar squared is both in this part of it and in this part of it. So we're going to get left with beta 1 plus the sum of x1i minus x1 bar times ui over the sum of x1i minus x1 bar squared. So we can't cancel these out, right? We got to be careful. We can't cancel these out because of this I here. It's over all the sums it's multiplying, so we can't cancel these things out. And so here's an expression for beta hat for beta hat 1. So our estimator of beta hat 1 equals the true value plus this. So now when we want to figure out the expectation to know if it's unbiased or not, or to know what the middle of the distribution and the mean of the distribution is, we need to take the expectations of both sides. And then we'll have to think about those assumptions that we had to make to help us out.